Hello everyone. In this short video, I'll be walking through the recent breach that occurred at Capital One. We'll talk about how the unauthorized access to the customer data actually happened, how a Rika-based solution could protect against these types of attacks, and finally, we'll walk through a brief demonstration and show you the product in action. Here, we have a very simple view of a fictitious company called My Insurance Company. While fictitious and set up for demonstration purposes, it is important to note that the principles and designs are the same as the breach that occurred at Capital One, from which real-world user data was breached and extracted. The My Insurance application allows for remote agents to log in, upload, modify, or retrieve patient information. Let's dive in a little further and walk through the various events that occur when an agent performs these tasks. First, the agent accesses the web or mobile application. They then have to sign into the application. In this case, they are using a single sign-on provider. Once they have successfully logged in and have access to the portal, they can begin uploading and downloading their files. It's important to note, though, these documents are actually stored on an AWS S3 bucket behind the scenes. Access is restricted here by a specific Identity and Access Management Policy, or IAM, role. But as you can see, if an IAM role is somehow stolen, as was the case in Capital One, there is nothing else protecting against the unwanted access. According to the latest updates from experts such as Krebs on Security, a misconfigured web application firewall in this case allowed the hacker to gain access to the role. Once the role was compromised, a simple sync command allowed the actor to mirror the data to their system with nothing further preventing them. Now let's take a look at the Rika-based solution and how we can detect, alert, and protect against this type of unauthorized access to the AWS S3 bucket. We have the same application here, as you can see, but this time we've deployed Rika-based microsensors. These microsensors act as security cameras on the network by observing the API calls and the data that is carried within these API calls. The microsensors are very lightweight, there is no code change required, and there is absolutely no disruption to the application itself. Rika-Bay in real time correlates the API calls as you're seen at different microsensors and across the various segments to identify and baseline the legitimate transactions. When a malicious actor tries to directly access data stored in S3 using the AWS command line interface, which we know internally translates all the commands over to API calls, Rika-Bay detects the anomaly in data access, sends an alert to the Rika-Bay console, while at the same time blocking the exfiltration attempt. Now that we have a basic understanding of how the data was leaked from Capital One, let's jump into a quick demonstration and show you hands-on what this all looks like in the Rika-Bay solution, and how Rika-Bay can help mitigate the abuse, misuse, or any misconfigured API-level security within your environment. Okay, so let's jump into the demonstration. As you can see, we have our fictitious website, My Insurance Company, and the application that gives the agents the ability to upload and download patient files. Since I'm an agent, I'm going to go ahead and click on the agent login. This will redirect me to my SSO provider and authenticate me. You can see the authentication was successful. Now that I have logged in, I have the ability to upload and download files. So let's go ahead and choose a file. In this case, I'm going to select the Honey Badger file and click on Upload. You can see here that the file has been successfully uploaded, and we've presented back several different links that you could use to fetch this file. Each one of these links refers back to the Amazon S3 bucket. For the purposes of this example, we're going to go ahead and grab this link, copy it, and move over to a new browser session that is in incognito or private mode. This represents an attacker or a malicious person that has not authenticated into the system. If we paste the link and try to access the file, we can see that we get a 403 access denied. This is exactly what we would expect while being protected with a Rika-Bay. Now let's jump into the terminal and see what's actually happening from the command line. So the policy that I have configured on this bucket does allow me to list the file just to show you that it does exist. So you can see here by doing a simple AWS ls, we can see that the Honey Badger file is indeed there. Now, if we go ahead and actually try to sync the entire folder, we will see that we will get an access denied. Now this happens because this bucket is protected by Eureka Bay. In the case of the Capital One breach, there was no such protections in place, and since the attacker had assumed the role or the IAM policy of the application, they were able to sync and exfiltrate all the user information. So now that we've shown that we can block access to the file, let's jump into the console and see what we see there. We go into the Eureka Bay UI, go over to Events and Policy Exceptions. We can see here that a policy was triggered. We can see that there was a file attempted to be downloaded from an unauthenticated user. And we get information such as the username, the client IP address, as well as the file name. We also show the entire alert or transaction in a JSON format. This is just a small capability of the Eureka Bay solution. For more information, please feel free to contact us and we'll be happy to walk through an extensive demo for you. Thank you.